Hi, good evening. I believe it's time for coffee. I hope you're not sleepy, everyone. Are you? Okay, my name is Shiva. I work with NPCI, National Payments Corporation of India, as a Deputy Chief of AI Build today. But in my past life, I was Deputy Chief of Tech Infra. So the story of SONiC happened, I think around 3 years back we started? 4 years back is what we started. That's a quick introduction about me. I think Chintan doesn't need any introduction anymore, does he? Yeah. You're missing what? I heard that. Even I've got to see that. So a quick introduction about NPCI. It's the central organization which is fundamentally running the fintech backbone. How many of you are using UPI here today? Okay, don't raise your hand if you're not using UPI. Okay, cool. So it's an umbrella institution formed by RBI and a consortium of banks. UPI is one of the services, but if you happen to see the entire portfolio, IMPS, AEPS, Aadhaar-enabled payment system, RuPay cards, NETC FASTags. So in a way, we say, whoever it is in India, they will touch us, we will touch them. So we touch every person residing in India. Well, talking about sheer volume, UPI, I think it is close to 1 billion transactions a day. We are somewhere around 680 million transactions a day. So one of the things, because it is a national critical infrastructure, we need to be cognizant about the fact that we cannot have a single vendor risk. So this was the time when we were migrating from the colos to our own the greenfield data centers. A single vendor risk was not at all okay, right? So we had a couple of challenges to bootstrap the entire data center. The main ones is what I'm trying to voice out. The first one is zero vendor lock-in. Second, siloed systems. We cannot have different fabrics, or we cannot have systems that can work in silos because we are talking population scale. Okay. Next thing is supply chain prices. When it goes to a single vendor strategy, what typically happens? We are now at the mercy of a single vendor who has to supply. And look at the national cause. Thanks to the people, thanks to everyone here, thanks to everyone out there who have helped us to build this ecosystem. But then, considering these three challenges, this is where we started our dialogue with Broadcom, and that's where Chintan happened to us. In other words, Broadcom and the SONiC ecosystem happened to us. And quickly, Chintan, over to you. How would you like to solve the vendor lock-in here?
So before I solve the problem, imagine you walking into NPCI and Shiva describes that every banking transaction that happens in the country goes through this infrastructure, right? So I was kind of frozen because you need to deliver something which is absolutely critical, right? This is something of national importance and you just have no room for error. Right? And what he said is bang on. They cannot have a single vendor. So he wanted an ecosystem which is open. So that is where SONiC came in because they have the choice of hardware. Second most important thing is they wanted something which can take the scale of 140 crore plus people. Right? So to give them that confidence that SONiC has been tested by hyperscalers at such large scale, it really helped. So, because it was born in the cloud, the programmability which they needed is something which SONiC has it inherently, right? So, as an engineer and as an Indian, I thought that this is actually the best solution for them, and that is why I proposed SONiC to NPCI.
Perfect. So quickly moving on. So we'll kind of try to do we say Jugalbandi, or a kind of a discussion. We'll take you back, we'll rewind the timeline a bit, and we'll see what happened during the initial conversations, how did it start. So fundamentally, again, constructing the backbone on which each and every financial transactions are happening. Think of the street vendor. Think of each and every place where we are doing payments. Let it be a 1 rupee payment to a 100,000 rupees, 1 lakh rupees payment. We need to adhere to a couple of design principles. So when I say design principles at NPCI, not just the network, but thanks. Not just the network, each and every component that we put in, each and every decision that we make, we ensure that there are checkboxes for each and every principle that we have. So quickly iterating, it is no brainer, Chintan. You have to go through this drill. And without this checkboxes all with a green tick mark on it, I don't think SONiC is making a place into NPCI, right? And no open networking. Yeah, you might have told it, thanks for your sales pitch, but well, we got to deliver. And the deliverables are precisely being driven by these principles. So quickly walking in, we need horizontal scalability at each and every layer.
We have been doing this, Shiva, for ages. A simple leaf spine claw network can solve your problem. You can scale horizontally, right? And to have like multiple horizontally as well as vertically, right? With claw network. So it's simple. It's a piece of cake for us.
Okay. So are you telling me that I need not worry about just leaf pairs, but we can do something different, scale horizontally in a different way? Or?
Yeah, I mean, scaling horizontally in a pod is possible. To make it even more resilient, we can have multiple pods.
Okay.
Right? And can also have a super pod, which kind of connects all of these multiple pods.
Sounds good. So you're saying that not just the horizontal scaling, but even the SPOF, single point of failure, can be taken care by the multi-pod architecture that we're going to design, or you're proposing onto the table?
Absolutely, absolutely. And what we will do is, we'll use industry standard practices like BGP with ECMP, right? And routing from the node itself.
Okay.
Right? So no switching at all. So we'll build something grounds up which has absolutely no chance of failure.
Cool. So I think you spoke BGP, ECMP. These are open specifications. So you're saying that they are going to be interoperable?
Absolutely.
Okay. So irrespective of whether the ODMs are going to change, because we are sticking to the open specifications, it automatically becomes interoperable because all of us are speaking the same language there.
Yeah.
Same protocol.
So the underlying hardware platforms may change, but the NOS running on top of it would remain the same. So your APIs on top of it would also remain the same.
Okay. You said API. So are you telling me now I have one homogeneous way to orchestrate multiple hardware?
Exactly.
Speaking one single language on open specifications and I'm not getting locked in anywhere?
Absolutely. That's the beauty of disaggregation.
Okay. So because you said REST APIs, so can I also check the highly programmable least or zero human interventions? Trust me, I'm a chaos myself. There's the reason I don't touch my laptop and I'm not in my best senses.
I mean, it is built in the cloud. So, right from even the first NPCI packet hitting the switch, it will go through the ZTP process. And when we do the ZTP process, all your required OS checks, right, your required security config will be in place before you actually move your network to the actual production stage.
Got it. How about observability? I think I just saw a story happening in the background. You brought a customer story to my table. How's that? You will assure that that's coming into my shop as well, right?
Absolutely.
Okay.
We'll use all the open tools to make it happen.
Cool. Last one, of course, I think you did voice out multiple hardware, multi-vendor ecosystem. So that way, we were able to quickly check all the boxes and say, okay, looks like we are moving in the right direction. And we'll quickly fast forward. What happened after a couple of weeks is a high-level circuit. Just a point to note, this is not the actuals. We are dealing with national critical infrastructure. So obviously, think of this as a wiring diagram, a simple loop, which can be replicated at scale, right? So this is a very bare bone what we have brought in onto the public eyes. It's national critical interest, so my apologies for not able to bring in the real world systems. But think of this as the basic wiring diagram, right? So Chintan, would you like to just quickly walk us through what's happening in this clumsy slide? My apologies.
Yeah. So it's a classic leaf spine. I'm sure all the network engineers out here understand. So considering the importance of the infrastructure, what we have done is we have built multiple pods, and all of these multiple pods kind of come together with an aggregation pod. And this is within a DC. What we also do is we have replicas right, of such multiple data centers. So you have multiple pods across multiple data centers where all the banks of India connect.
So, so this is kind of an application. So think of this as a micro cloud by itself. A single class. Now we'll have multiple such class architectures, which are all getting aggregated. I'm sorry for the people out there. You'll see 3 circles. The one on the top is the data center integration, the DCI layer, and the one on the right is just a magnified version of the smaller one on the left in the bottom layer. So in the expanded version, what we also chose is we will use Kubernetes for our fundamental orchestration of application, but we will ensure that we need to make the network aware of what's happening on the Kubernetes layer as well. So I think during that process, we faced 3 major challenges. So the first one, we had to ensure that the Kubernetes CNI and SONiC can speak to each other. Can we fuse them? That was the first challenge. The second one was external traffic to ingress. Now, if in the public clouds like Azure, there is already a load balancing solution that's a managed load balancer, ALB, if I'm not wrong. I'm sorry if I'm coining it wrong. Sorry? SLB, so Azure. I'm sorry, I'm a little not so very savvy with Azure, but the other ones. So there is a managed load balancer, right? So the load balancer is actually fusing your AKS in Azure Kubernetes service, right? So it's doing the fusion, right? But in a classic data center like ours, we need to do some kind of fusion. And we didn't want to bring in again a pair of load balancers because that load balancers are working in an active passive mode. So the only possible way is vertical scaling, not horizontal scaling, but think of UPI. It is a tight slap on these devices. It's not an easy workload for sure. That's the second challenge. The third one, yeah, so let's try to understand the ecosystem and payments, especially when it brings to UPI, right? Look at these legs. Nykaa or Flipkart or Amazon is doing a flash sale. They are a merchant. The merchant is latched to a bank. The bank has and then the merchant has a payment gateway. The payment gateway is again hosted through a bank, and that bank is connected to UPI. So the number of hops, the supply chain is so huge. So by the time a merchant runs a flash sale, that information comes to us. Trust me, the flash sale is already over. So we got to be ready, which means we need to have an ability to scale out exactly the way it happens in the public clouds, but in the data center premises. So that was the third challenge, dynamic addition of nodes into Kubernetes, because if we're able to bring in the computing power, Kubernetes will take care of the application layer getting scaled out, right? So some classic old school problems that we face during this design. So Chintan.
So why not we discuss the
Sure.
fix that we had for each of these problems. So yeah, the first problem is you want SONiC and the CNI to be interoperable. How do you think we can do this?
Cool. So fundamentally, it was my platform engineers who were doing this fusion for us. They were sitting on a table, and we said, look, how can we actually eliminate the load balancer? In Kubernetes, we have something called as a service, and then there is an ingress. The purpose of ingress, or now there is a load balancer in the new Kubernetes versions. And in 1.34, they have even introduced the local first, which means least latency first. How can we bring that into the data center network? How do we make that available? So the easiest way is to actually leak the service network of Kubernetes into the SONiC itself. So that was our fundamental thought, right?
Yeah.
So how about think of my platform engineer as a bot sitting on these nodes, and my engineer understands both the Kube APIs as well as how the BGP advertisements are happening. Why don't we try to do something about it, write a small fusion layer, and we named it as Cosmolet. Like Kubelet, we named it as Cosmolet, and Cosmolet actually does 2 things. One, it has a declarative YAML. You can define the namespace and name of the service, and just deploy it. It gets deployed as a daemon set, right, Chintan?
Yeah.
And it runs on every node, right? And it is speaking Kubernetes language. So because it knows the namespace and the service name, using the configuration already present on the deployment of that particular application, its service, it knows what is the health check parameters. So there's a readiness probe and there is a liveliness probe. Daemon set, the Cosmolet also does the same thing on the left-hand side. Now, once it identifies that this particular service is healthy, then there is FRR running on the node, which is actually bringing BGP to the node.
Yeah.
So what we typically did is like we did a BGP peering to every node in the system, and then Cosmolet now just simply instructs the local FRR to leak that service IP from that particular node. But then what happens next?
Yeah, so because all of this happens automatically, we wanted a solution where you don't go in and configure BGP. It has to be automatic. So we used IPv6 unnumbered, right, with security. So we had our keys which would be rotated on timely basis to ensure that whenever we are peering with the right set of servers, right, and not compromising on security. So this is how we kind of ensure that we keep pace with Kubernetes auto scaling, and at the same time we don't compromise on security at all.
And I think the second challenge, the third challenge is what we use the IPv6 unnumbered with the security keys rotating at a different intervals for different peers. Now on the scale out, we were speaking about load balancers not able to scale out, right? The fundamental bare metal load balancers. Now, because we chose to use BGP with IPv6, and then they slapped it with ECMP, equal cost multipath, and then we brought in BFD as a sidecar, bidirectional forward detection. Now we are able to quickly not only just expose the service IP from one node, but from all the nodes with equal cost. So the previous hop or the hop above now has multiple paths available for a given service. Now BGP, we can make the session and how do we want to distribute on ECMP. Those are precise programming ability already available in BGP. So fundamentally, the way we achieved the horizontal scalability is by fusing the SONiC to the Kubernetes CNI and making use of the open specifications. The best part was the reason why we chose FRR is we were confused between BIRD, FRR, and we were doing a lot of research. Then we tried doing a lot of benchmarks, and lastly we settled with FRR because we peeked into SONiC again. It being an open network, we looked what is the software which is running on Linux, which is doing the BGP on SONiC and can scale for so many platforms out there. We saw FRR running. There was no second thought. Then we did a little more research. We added that data. We quickly saw that FRR is a straightforward solution for us to choose. So on our bare metal servers and whatever Linux operating system flavor it is, we ensured that we are doing a version locking quickly. We provisioned that. We have a different way of doing all that in an automatic way. With that, we were able to now achieve or say solve all the three challenges. Namely, first one, we were able to fuse Kubernetes CNI to the bare metal network, SONiC, without having any lock-in to a specific CNI. Mind you, the CNI is doing its own job in Kubernetes. The SONiC is creating a multi-ODM fabric. Now, without having any kind of lock-in. So tomorrow, if my application developer comes and says, look, Shiva, I'm not happy with CNI A, I want to move to CNI B in a different part, we are not locked in. So the BGP pairing between the CNI and SONiC, we just decoupled that. And we said, let's do it seamlessly like how humans do and code this. So that's the Cosmolet, what we specifically spoke about. ECMP, horizontal distribution, just think of spraying the TCP sessions. And then the third one, because it is IPv6 unnumbered with security in place, now when there is a demand surge or when there is a trend, we have our own deep observability layer which uses eBPF and open telemetry. So using those insights, we are able to predict quickly if there is an upcoming load based upon the trends, hour on hour, minute on minute, day on day, a lot of heuristic calculations. And then quickly we can actually move nodes from our inventory to inventory cluster to the, let us say, a UPI cluster or some other application like IMPS, let us say, and then we are able to scale out from there. Kubernetes seamlessly takes care of it. But I think, Chintan, the other one, what you said, the contention on the switch, and then bringing that into this ecosystem, that's a bright idea. We should definitely take a look at that as well.
Sure.
That's observability. So we do it this way. So of course, I think that has opened a couple of eyes. 9 minutes, guys. We are open for questions.
Anyone has a question? Yeah. I will pass.
This is Ryan from NextHop. Could you comment on your production-related challenges in the network? This looks really great. Curious to hear about the challenge, the bad parts.
I've been voicing this out, of course. See, one of the challenges that we face today is not just the patch management. Yeah, of course, it's not very specific to SONiC, but the reason why I'm putting it at this stage is because end of the day, when I look at SONiC, it's a bunch of containers orchestrating the SAI, orchestrating the chipset through the SAI. Can we actually look into this problem statement of rolling out firmware upgrades in a more seamless way? Today, what typically happens is my operations engineers, the ones who are sitting out there, they burn an entire night to perform firmware upgrades on these switches. So think of the fabric, right? So in the fabric, I have the blue greens, of course, yes. But when we need to run a firmware upgrade, the fundamental challenge is that it might bump up the FRR version, or it might bump up the version of some other software, which is already there. So obviously, when we start that activity, we need to ensure that the entire fabric, at least the leaf layer, is completely patched overnight. Because we are dealing with massive loads. So you can see, so if I were to give you a math, 50% of UPI's workload is running on SONiC today. That is close to 330 million transactions a day. Each financial transaction attracts 22 API calls. So we can do the math. That's close to 6,000, 7,000 API calls per second is what we're clocking. Is it? Yeah, right, per second. So in that massive scale, when my engineers are actually patching, though we have multi-pods, multiple data centers in place, the fundamental challenge that we face is when the patching is happening, we cannot leave it in between. So it has to be one single night activity. Can we actually look back into this? Because I feel this is a bit old way of doing it with the modernized workloads and with containers in place. I have a feeling we can actually look into this as a problem statement. I've been keenly deep digging into it, but I don't think I have enough capability to do that. End of the day, I'm a network and platform orchestrator, but this needs sheer knowledge and deep knowledge to look at it, because it's not as simple as like a Linux kernel, because it's not just one kernel. There are two actually, as I understand. There's a network chip, and then there's another small chip on which the operating system is booting up. So this is one of the challenges. So let it be a bug or let it be a security patch rolling out. It's an entire firmware upgrade, the entire fabric, and then the rollback process is also a little tough in place. I feel this is something that we need to definitely work at. But otherwise, the community has been doing great. The ecosystem has been pretty great. We are getting the right kind of support. So our best bets were to kind of choose something which can give us the freedom to choose our hardware, achieving the multi-vendor strategy, so no single vendor risk, but at the same time also have the flexibility to move faster. Yes.
Shiva, great story, and so encouraging to see NPCI deploying SONiC across the board. You mentioned ECMP between leaf and spine. Do you plan to switch that to UCMP for better utilization of the connector?
So ECMP, our choice was, the reason was we can actually also do weighted. So there are many scenarios where, for this, actually, I'll take one step backwards. We need to understand how UPI or financial transactions work. Fundamentally, I'm sure most of us must have gone to a bank. When you go to a teller, you take a token. You're not served right away. You take a token, and your token is called out. So what's happening is taking a token is placing a request, and then your token being called out is when your request is being served. So that's called a callback flow. So in the financial ecosystem, these are not synchronous APIs, these are asynchronous APIs. So there is always, just think of it, you're doing a balance check of your account through UPI or even IMPS you can use, right? Every call is actually, you're placing it to NPCI, NPCI does a call to your bank, okay? And then we don't get the response. All we get is an ACK with a token number. Just think of it virtually. Right? And then the bank gives us a call back with that token number stating that, hey, oh, you asked for the balance of so-and-so person, and with you have ensured that the right authentication and authorization are done. So here's the bank balance, and then we relay that back, right? Now in this asynchronous flow, what typically happens is there are a lot of times where the balancing is not even. And the major banks, there are certain banks which are literally handling 60% of the total transactions. So when we actually look back at the application ecosystem, and then when we trickle it down back, we need to have certain manual gears in our hand. So that's where we chose ECMP, so we can actually give weighted as well. Using simple REST APIs, we can quickly reprogram and we can redistribute the load. But at the same time, UCMP, good question. I don't have straightforward answer. I could justify my ECMP, but that's a good read. I'll go back, I'll take a look. Maybe we can sync up offline.
So let me add to what he said. This workload, if you see, is pretty different. This workload is where you have, it's completely opposite to like the workloads which are emerging today, AI, where you have one fat flow. Here you have millions of flows, and which are like very short-lived. So it's important, right, that you have full control on the infrastructure that you have. You can do unequal cost multipathing as well. But what you need is predictability, and which you easily get with ECMP.
Dedicated links.
And what we have already done is, because it scales so, I would say smoothly, congestion is not a problem. But you need all of these things for redundancy, right? And that's where your choice of protocols come into picture.
Makes sense.
And the way the softwares are created, so NPCI has its own architecture called as BDA, billion a day architecture, right? We have ensured always that we are independent of the underlying infrastructure. In other words, UPI can be literally run on any environment, provided that environment respects open specifications. So that way what we have done is, we have built in so many logics into our app layer, and our choice of software is also Java, which is a classic banking ecosystem. And our softwares are open source. So we're a great fan of Linux Foundation that way, thanks to them. We're able to build at scale. The support ecosystem is there. So everything is open. So that's why our choice is like, let's not create too much dependency on the underlying infrastructure. We should keep it as open and as flexible as possible. So today we have BGP, tomorrow maybe 5 years down the line with AI and everything, if there is a new protocol, and if it can do better than what BGP is doing, we should not shy away in looking at it. And we should not have that mindset of, hey, we know for sure the known devil is a good friend than an unknown angel. So that's the ideology there.
Absolutely. I do have a follow-up question. So you mentioned scalability, adaptability, programmability, and observability, right? Some of the key highlights that you had as key considerations when you chose SONiC. Security is a big element to what you do. And I'd like to understand, when you chose SONiC, what did you see in SONiC delivering on security capabilities as compared to other proprietary network operating systems?
Well, security is a topic that I'm not authorized to speak about because this is national critical infrastructure. Apologies for that, my sincere apologies, because these are trade secrets, or these are the key things which are keeping us really secure. One thing what I can tell you is, when compared to the, our comparison is directly with the other vendors, right? It's always a fist fight there. What we have is, we have certain standards that we stick to. What I have clearly voiced out here is the availability and scalability only. Purposely, security has been conveniently stashed away because we are not talking about it. All we saw is SONiC helping us achieve what we're achieving on the other networks? As long as the like to like is happening, we don't mind if something better is happening, but we are very cognizant or we are very cautious, nothing less should happen. That's happening, we are happy.
Absolutely. Well, that's a great remark. I mean, saying that SONiC delivers on what you expect. So good. Thank you for coming and joining and sharing your story here.
Pleasure. Yes.
Hi, this is Arif with Nextop. I'm curious about the talent that you have. Was it hard to find to run the network? Was there a certain type of engineer you were looking for? Where did you look? How did you look? Just curious in terms of the market.
So frankly speaking, in India today, there is a scarcity. Let me admit that. The ability for us, so when we go hunting for people to hire them, having people knowledge on SONiC, open networking ecosystem, forget that, even open source ecosystem is a great challenge today in India still. But at the same time, the good thing is there are partners who are willing to come in, who are very much deeply focused into it. So we strike a balance in having core teams, but one of the factors, sorry, I forgot to mention this, the reason for a homogeneous NOS with heterogeneous hardware is to ensure that the learning curve of engineers is not getting difficult every day. So the life of a day 2 engineer, I feel really sad. I've been a part of TAC in my past life. I've been a TAC engineer myself. I've been in a customer facing role myself. I know what kind of pressure it burns down for both the parties, right? Being a customer, so I've been on both sides of the world. I know how it trickles down. And then there are a lot of emotions flowing in when it comes to the national critical infrastructure, right? So choosing the right clan is not just about building skill, but also ensuring we have a good partner ecosystem, right? So that's why we did not go to anyone, but rather we chose to go and speak to the most very well-known silicon for network, which is Broadcom. We went, we spoke to them, and our first choice for it was, we started with Dell SONiC, then we brought in EdgeCore, then we brought in UFI, now we are talking to Celestica. So the whole idea was, we are placing bets in a calculated risk, because we know some of our own experience, we learned from our own experiences from the past. It's a 2009 established organization. We have burnt our fingers. It's not like we did not make any mistakes. We did. We did make mistakes. We learned from them. So there are certain principles guiding compasses which clearly give us the directions at the board level, saying like, hey, you know what, when you decide something, these are the factors that are influencing your decision for sure. Right? So one of the critical one is the support ecosystem, the skill availability. So we tried our best to balance it out. Today we have engineers who are familiar with SONiC, who are familiar with other silicons as well. But at the same time, we are also having partners who are coming and supporting us for the extended journey. So like the design, it's not just like we did it in our office, but we also ensured that before it hits the production, there are multiple people, multiple parties who are validating what we are doing. It shouldn't be a foot in the mouth situation. End of the day.
Great presentation.
Thank
you.
And what I'd love to see is the scalability SONiC is managing when you're talking about the rate and the math, the API versus call. I was like, amazing.
Right. So as I've said, the open source ecosystem is what we love. So we are now writing a small piece of software which will use both GNMI, as well as we're trying to bring in the element of eBPF and then extend that to SAI's APIs. So we can actually bring in the telemetry. So sometimes we call it this way: don't engineer, work like a stupid. Yeah, think like a stupid. Because when we're dealing with such large scales,
Yes.
we don't want to overcomplicate with complex engineering elements. Sometimes, if throwing a bare metal at the problem statement is solving my scalability problem, we will not shy away. So sometimes when deep problems occur, we say to ourselves, think like a stupid. What would a stupid do now? Move the traffic to a different side? Yeah, just do it.
That's what we do also sometimes, by the way.
I mean, it's necessary, right? Sometimes
Whatever
you
is
need to come down to.
whatever is fastest, we do that.
Yes, the recovery
and
time.
then later we can drink
Later
a
you
cup of coffee and become
retrospect.
smart.
Introspect, we can have good coffee sessions, beer sessions, and then there would be good board meetings as well.
Thanks a lot. Great adaptability session. Thanks a lot, Chintan. Thank you.